Okay, so today we're going to start out though by doing a little review here, okay? So let's review. What you do to one side of the equation?
Do to the other.
You do to the other side. Fill that in your notes, please. This is review. Every time we write something down, it lodges itself in our brain. What you do to one side of the equation, you do to the other side. So it doesn't matter what you do, you just do the same thing on the other side. And we call that, when we are doing something to both sides of the equation, what we do is we're trying to solve it, so we do something called an inverse operation, right? What's another word for inverse? What did we decide?
Undo.
Undo. So when you hear the word inverse, that's what I want you to think. I want you to go, oh, inverse, undo. So how can we undo addition?
Subtraction.
By subtraction. And how can we undo subtraction?
Addition.
By addition. But I'm going to throw a little twist in that today. Sometimes you can undo addition by doing addition. Does anybody think they know when you can undo addition by doing addition?
There's an integer in the problem.
When there's an integer in the problem. That would not be the reason.
More or less negative numbers.
Or what?
More or less negative numbers.
More or less negative numbers. Okay, well integers are some of the integers are negative numbers. So he's kind of on the right track.
So if you have two negative numbers.
If you have two negative numbers, no, it doesn't have anything to do with having two of them. Okay, why don't you find objective number 3 in your books right now on page 18? Remember, the objective is above the example. What is the objective?
Solving by adding the opposite.
Solving equations by adding the opposite. So what's going to happen is we're going to use addition to undo addition. And if you look at example 3 right now in your books, you just take a little glance at the one that they have there. They have an equation there, right? It's solve negative 8 plus b equals 2. Well, negative 8 plus b equals 2. What did they do to undo that?
Added.
They added, but there's addition going on in it, isn't there? Yeah, there's addition in it already, but yet they added to undo it. To solve it, they did addition. But what did they add?
8.
They added a positive 8 because that is the opposite of negative 8, isn't it? Okay, so when a negative number, here's our thought process we're going to have. When a negative number is being added, we're going to add its opposite to both sides. So we're going to look at that, we're going to say, oh, there's a negative being added to the variable. So I'm going to undo that by adding the opposite of that number. Stay with me, thank you. Okay, well what does opposite mean then? The opposite of a number is the other number on the number line, the same what?
Distance.
From 0. Same distance from 0. And we can't use that word opposite just loosely. It means specifically that. If you want the opposites of each other in math, you're talking about two numbers that are equal distance from 0 on the number line. You can't say that addition is the opposite of subtraction. No. It's the inverse of subtraction. Opposites. Two numbers that are the same distance from 0 on the number line. So what's the opposite of 4? Negative 4. They both are how many units away from 0? 4 units away from 0. How about negative 10? What's its opposite? 10. They're both how many units away from 0? 10. Well, what's the opposite of 1/3 then? Negative 1/3. Because they're both how many units away from 0?
1/3.
1/3 of a unit. What's the opposite of a negative 5/10?
Positive.
Positive 5/10. Again, they're both how far away from 0? 5/10 of a unit. What's 5/10 the same as in a fraction? 1/2. So they're half a unit away. Okay, so we have to make sure we understand, we gotta add the opposite, then we gotta understand what opposites are. Okay? Anybody have any questions about opposites? So when I put that on the quiz, you're gonna be able to tell me what an opposite is and give me some examples. Okay. Then let's go to the check it out problems below that example. I've written the first one down for us. It is -2 3/10 plus m equals 7. Now, what do you think? Is that a hymn? Remember, you're going to give me this, the whole thing so I know? Is that okay, Malcolm? What do you want me to do?
No, I was looking at the screen and I was like, are you recording
Yes, I am recording,
us?
but it doesn't take our picture. But what we're saying right now, yes, it is recording. Okay. So here's what I think we should do though. I think whenever the variable isn't first, because there's addition here, can you add in any order you want?
No.
What do you think? Can you add in any
yes.
order you want? Is 3
Yes.
plus 4 the same as 4 plus 3?
Yes.
Oh, so can I change this to read like this?
Yeah.
So can you go ahead and do it on your paper. So m plus -2 3/10 equals 7 is the same thing as -2 3/10 plus m equals 7. Because now we can see that a negative number is being added to our variable. So anybody want to offer up what they think we should do? Next. Go ahead, Isaac.
Add 2.3 on both sides.
Add 2.3 on both sides. Can you tell us why, Isaac, we want to add 2.3?
Because it's the negative number united to m by itself.
It's the opposite of the negative number, isn't it? Yeah, it's the opposite. Remember, when we see a negative number being added to the variable, we're going to add the opposite to both sides. Because these guys are the same distance away from 0. So if they came together, that'd be 0. And so the only thing we have left now on the left side, these guys are going to take care of each other. We have m equals
9.3.
Okay, and can I make this into 7.0? Is that okay? We can do that, can't we?
9.3.
So 3 and, so 9 and 3/10. There's our, what is that called again? That's our solution. That is our solution. Okay, we're not done yet. What do we have to do?
Check it.
Check problem. Okay, let's do our check problem. We write down the equation as it started, how it was given to us. We make a nice T under it.
Substitute the m for 9.3.
We put our 9.3 in place of the m. We do a substitution step. Some of us are having a little bit difficult time understanding what this checking means. We're not solving anymore. We've already solved it, you guys. We're done solving. We're just checking to see if it makes the equation true. So we put it back in and we check to see. But we work down. So what did I do? I put the wrong thing here? No? Okay. What do you think then? What is a -2.3 plus 9.3?
It should equal 7.
It should equal 7. That's because we want it to, right? But does it? Does it really equal 7? Is a -2 and 3? Can we think of this like money instead of using our calculators?
Because if you add the negative 2 and the 9, that's 7, and then the 3. Oh wait, the 3 and the 3 wouldn't that like cancel each other out?
So what really happens when you're adding a positive and a negative is you kind of end up doing a subtraction problem, don't you? Yeah. Okay, let's think of it like money. If I have $9.30, could this represent $9.30?
Yes.
Stay with me. Could this represent $9.30?
Yes.
Okay. Could this represent giving away $2.30?
Yes.
If I give $2.30 of my $9.30 away, how much money will I have left? $7. Yeah. It checks out, doesn't it? Okay. Again, we're still doing these nice check problems, so someday I will let you out of them, but not yet. Okay, any questions? Okay, turn your paper over and we're going to do the other two check it out problems. So 3B, would you write down the equation as it is given in your book? Any suggestions what we should do?
Add 3/4 on both sides.
Why are we going to add 3/4?
Because it's
What's
negative
the
opposite.
thing we're going to look for today? What's happening in this equation, you guys? Let me have these two trade places because it's addition. Let's have those two trade places. It's addition, they can. So after they trade places, now we can see that Z, the one we want to isolate, the one we want to solve for, has something being added to it, and that something is a negative number. So whenever there's a negative number being added, we're going to add
It's opposite.
its opposite. Destiny, what's the opposite of negative 3/4? Positive 3/4. So we're going to add 3/4 to both sides. Tell me, when you work with fractions, do you like to add and subtract them? Or do you like to multiply them and divide them? Which ones, do you have a favorite without your calculator?
I like to add and subtract them.
Why do you like to add and subtract them, Dakota?
Because it's a lot easier.
Because it's a lot easier. Okay, what do you have to do though when you add and subtract them? What's really important before you can add and subtract
Make
them?
sure the bottom of the denominator is the same.
You have to make sure they have the same denominator. So if they don't, you have to make that happen, don't you? Okay? Well, we're adding. These guys take care of each other. They cancel each other out because they're opposites. And do these guys have the same denominator?
Yep.
Yes, they do. So we end up with Z equals how many fourths?
8
8/4,
And that is 8.
which can be simplified to 2. So we say our solution is 2. Okay. The check problem on this one gets a little trickier when you're not using your calculator. Check. We have our negative 3/4 plus our Z equal to 5/4. And we have to check it out. Substitute in 2, so we have negative 3/4 plus 2, and we got 5/4 on the other side.
So would it matter if I still used negative 8/4 or 8/4?
Okay, so what we should do then is, now that we've put 2 in, we should say, I think this would work a lot better. It'd be probably a little friendlier if I would rename 2 as 8/4, right? Because now everything will be fourths then. And now we put these numerators. By the way, when there's a negative sign on a fraction, who gets that negative sign, the numerator or the denominator? You typically would give it to the numerator, but either of them can have it. But we're going to give it to the numerator because we want those 4's to stay matching. So negative 3 plus 8, what's that?
10/4.
Carol, what's negative 3 plus 8? So you have $8 and you give 3 of them away. 5. It would be a 5/4. And then bring this down over here. It's a 5/4. So it does check out, doesn't it? Now, if it doesn't check out, what if it doesn't check out? What is that really telling you?
That you need to find a different number that actually works.
Yeah, you possibly got the wrong solution. Sometimes you could possibly be doing your check problem wrong, but typically what it's supposed to tell you is, I got the wrong solution for this, okay? Okay, I want you to write the last one down, I want you to do it yourself.
Done.
I'm not going to guide you through it. Hold tight then. Destiny, head up for me, please. Thank you. Dakota, come on up and be the teacher. solving, please, not the check problem, just your solving. By the way, you can't rest your hand on the board because that's what happens here. Is this right here? I forgot to tell you that. Don't rest your hand on the board while you're writing, okay? Thank you. You can put the pen in the tray. How many of you that are done solving agree with Dakota? Do you agree? That it is 40, x is equal to 44. Notice Dakota uses the t thing even for his solving, which is okay. That works. It's working for him. So, should it check out then? If it is truly, we could check to see if it, who wants to come up and do the check problem for us? Come up. Who wants to do the check problem? Go ahead, I just want to bring your paper with you in case you might need to use it to refer. Remember, your hand can't rest on the board, only the pen can.
Okay.
And by the way, if you ever come up to write on the board also, in the smart board, if you just hold the pen in your hand, your finger becomes the pen, you just write with your finger. So you don't have to worry about it.
Next time. That would be a lot easier.
Okay. Thank you, Isaac. Okay, explain to me why, in some sort of, worldly terms, why negative 11 plus 44 on the left side of the check column is 33 without your calculator. Why?
You're kind of technically subtracting 11.
Well, I want it in worldly, I don't want it in the mathematical way it works, I want it in the world, some sort of a, something that makes sense to us in our world. Rose? You what? You can talk louder for me.
Because 44 positive 44 is greater than negative.
Okay, positive 44 is greater than negative 11, so what does that tell us? How does that get us to 33? Desi, you want to help us out?
You have $44 and give 11 to a friend or something, that equals 33.
Yeah. If you have $44 and you give $11 away, do you have some money left over? Yeah, it happens to be $33. What if it's 44 degrees above zero, like maybe it was this morning when we woke up, and the temperature goes down 11 degrees, where's it going to be? It's going to end up at 33 degrees. Dakota?
I was gonna say, if you have two different integers, then you're either, I guess you're trying to figure out what the number is.
Okay, and I think kind of what you guys are trying to explain to me is how does it work out mathematically? What's the algorithm? What's the rule for why when you add a negative to a positive do you get the answer you do? So there is a rule for that, isn't there? And that's what you're trying to explain to me. Okay? So we're done with our notes. You can get out a sheet of loose leaf paper.